This is section 3.3, page 166, number 17. A card is selected at random from a standard deck. You can take a look at what it makes up a standard deck on the bottom left corner of page 136 in your textbook. Find each probability. So first we're going to find the probability of randomly selecting a diamond or a 7. Now we're only choosing one card, so we need to look at whether or not they're mutually exclusive. So first we're going to find the probability of selecting a diamond. So the probability of selecting a diamond, and then we're also going to look at the probability of selecting a 7. So we're going to add the probability of selecting a 7. And now since they are not mutually exclusive because you have a 7 of diamond, we're going to subtract the 7 of diamonds. The probability of the 7 of diamonds. So how many diamonds are there in a deck of cards? Well, there's 13 diamonds, there's one suit. There's 4 suits. There's diamonds, clubs, hearts, and spades. So 1/4 of the 52 is going to be 13. Plus the probability of a 7, there's 4 of each number, so it's going to be 4 out of 52. And then we're going to subtract the 7 of diamonds, which is the 1 out of 52. So that'll leave us with 16 out of 52, which reduces to 4 out of 13. In decimal form, rounded correctly, it's 0.308. So it was 3076, and then you look back at that 6 to tell you whether or not to round up to 7, and the 7 becomes an 8. Let's take a look at part B. We're asked to find the probability of randomly selecting a red suit or a queen. So that's going to be the probability of selecting a red card, plus the probability of selecting a queen minus the probability of selecting something that happens both. This is not mutually exclusive either because you can get it both at the same time. So that's going to be a red queen. So red cards are the diamonds and the hearts. And so there's 13 diamonds and 13 hearts. That leaves us with 26 red cards out of the 52. Plus the queens, there's 4 of those out of 52. Now we've already counted 2 of them over here. We've already counted the queen of diamonds and the queen of hearts, so we have to subtract those back out so we don't count it twice. So we're going to do 26 plus 4 minus 2, and that'll leave us with 28 out of 52. And so you can reduce that, and that'll give you 7 out of 13 in the form of a decimal. It is 0.5384, but if they just want 3 decimal places, make sure you round correctly, and that would give you 0.538. Let's take a look at part C. We're asked to find the probability of randomly selecting a 3 or a face card. So that's the probability of getting a 3 plus the probability of getting a face card minus the probability of getting both. Well, in this case, they are mutually exclusive. You can't have a 3 and a face card on the same card. So these ones you don't have to worry about subtracting anything. Well, there's 4 3s. There's a 3 of hearts, clubs, diamonds, and spades out of 52 cards. Now a face card is Jack, Queen, King in the deck in each suit. So you're going to have the Jack, Queen, King of diamonds, spades, clubs, and hearts. So that's going to be 3 of these times the 4 suits. So that's going to give you 12. 12 face cards in a deck over the 52. And so we're just going to add these together. We don't have to subtract anything in this case. And that'll give you 16 out of 52, which reduces to 4 out of 13 and gives you a decimal. 4 decimals, it's 0.3076. But since we went around correctly, that 6 tells us to make the 7 and 8. 3, page 168, number 24. A person is selected at random from the sample. Find the probability of each event. And so here we're looking at the dominant hand and the gender, men, women, and lefty and righties. And so when you've got a table like this, it makes it a lot easier to actually calculate stuff. You can just look up stuff in the table, decide what they're looking for, and look at the table to add up the numbers or not. The person is left-handed or a woman. So left-handed or a woman, or means that we're going to add always. So a person that's left-handed are these people, or a woman, so we also include her. So it's just going to be 63 plus 50 plus 425. So when we add those together, we end up with 538. And the total here is 1,000. There's no give in here. So it's just 538 out of 1,000. And that's going to give us a decimal of 0.538 for part A. Let's take a look at part B. The person is right-handed or a man. So very similarly, the person is right-handed over here where they've got the righties, or a man. So or again means we're going to add the right-handed and the men. So that's going to be 63 plus the 462 plus the 429, and that would give us a total of 950, an awfully large amount. And so 950 out of 1,000 is going to give us 0.950, or 95 hundredths, for part B. For part C, we're looking for a person that is not right-handed or a man. Well, if they're not right-handed, that means that they're left-handed. So this is the same as saying that they're left-handed or a man. Okay, so again, that's going to be adding with a man. So left-handed, right up here, and the men. So we're going to add together the 63, 462, and the 50 for part C. And so that'll give us 575, and 575 divided by 1,000 in the form of a decimal will give us 0.575. And if they want a fraction, just make sure that you reduce it. I think a lot of times they're going to want you to round a decimal correctly. The next one is part D. This is a little bit different. It says the person is a right-handed woman. So in the case of a right-handed woman, that means they're right-handed and a woman. So it's not or here, we're not going to be adding. You just want to look for a right-handed woman. And so the right-handed woman is just 425. So it's going to be 425 out of 1,000. And that would give you a decimal of 0.425. For part E, it asks, are the events being right-handed and being a woman mutually exclusive? Explain. And so they are not mutually exclusive, because you can have a right-handed woman, a right-handed person being a woman. So since the two events can happen at the same time, then they are not mutually exclusive.